if I can set up a tunnel so easily already, why do I need to use my video transport solution like RIST in order to set up a tunnel for me? So please explain.
Okay. Yeah. Think of this notion. Until now, the tunnels that you had, they were only pipes. Any packet recovery, any retransmission, you will have to use the standard protocols, TCP, you will use simple profile RIST, and that will go through the tunnel. Setting up the tunnel is very easy. The RIST tunnel will be very easy for you. You decide whether it's a server or a client, you decide what kind of an encryption authentication method you want to do. It can be PSK, it can be DTLS, it can be even WireGuard. But unlike the traditional WireGuard, suddenly we will provide protection. Now you don't think about recovery. The tunnel itself, it's like going on a turnpike. They will provide all this, the tunnel itself provide the services for you. If a packet gets lost, the tunnel itself will do that instead of you. So if you want to carry TCP from New York to Australia, with the tunnel, you don't care about any TCP retransmissions.
With the RIST tunnel?
With the RIST tunnel. The RIST tunnel will do the retransmission for you. Hold on, don't jump. Now, on top, you can also decide as advanced users whether you want to expedite some of the traffic, prioritize some of the traffic, so you now become a more advanced user. So if there is a TCP traffic that is much more important and you don't want to wait to hold it so that the TCP itself will do the retransmission, you can. Mm-hmm. So suddenly there is a tool that gives you much more capabilities than any VPN, commercial or open source, available today to do that.
Right, so let me make sure that, let me try to summarize what I think you said, is like, if I'm using a tail scale, tunnel, which is a WireGuard tunnel, and I'm sending a RIST stream over it, and I'm also doing like HTTP stuff, TCP-based stuff, that the tail scale, any errors that happen when the tunnel is going on, the RIST stream will take care of it itself, and the TCP stream is up to its own devices to be able to fix over tail scale.
Using something other than the RIST Advanced Profile.
Right, if I'm on like a tail scale, a traditional WireGuard tunnel, but if I use Advanced Profile tunnel from RIST, then it is going to be fixing the packet loss before the TCP system ever sees it.
You can select.
And I'm wondering, like, have you actually tested that? Is that true, or is there some kind of a strange interaction that might be occurring?
I can tell you that before starting the bucket list for the RIST Advanced Profile, I did a project like that. It's a skunk work project that we tested the technology. And yes, it is amazing. We used TCP proxy, so that we basically said to the TCP, hey, don't worry, it's a long haul. We will just give us that, we will acknowledge the packets, and I can tell you, for instance, we tried to do, we tested that to deliver content to Twitch. And what we did, we had a problem, so let me explain what we did. The problem was that we had a limited upload bandwidth. We have a Twitch e-game, we have an e-gamer fellow with Twitch, and he had an upload problem. So the first problem was that we needed to bond interfaces, and we couldn't. So we did something which is like the RIST Advanced Profile, and we bonded. And then we saw that the Twitch wants to receive RTMP, which is TCP-based. So we terminated that TCP-based at the source, carry that using RIST to the destination, and then output that. So all the packet loss that was from the source to the destination, which was about 3%, which limited its ability to cross over, just flew out the window, because RIST, 3% packet loss for RIST is a joke. Like, RIST can do 40, 50, 80% packet loss if needed, and that solved the problem. So suddenly, we could increase the upload from 2 megabits to almost 8 megabits, take all the packets packet loss, that the TCP will shorten its window or increase the window, depends on the situation, and that went out the window. So while the advanced profile is still, there's no commercial implementation of that, it is doable, and it was tested to achieve that.
What are you guys waiting for? The spec's been out for 3 weeks now.
The problem is that we need to travel every few weeks, coming here,
all right.
there.
All right.
Yeah.
Don't whine to me about your personal life.
And yeah, we have to go to sit in AG meetings and
There you
write
go.
documents.
Oh, those terrible AG meetings.
Yeah.
But I know what you mean, Mike. There were, way back when, there were TCP-based VPNs, and those had very, very weird interactions, TCP over TCP, that basically they stopped working after a few days. But this is the other way. You give TCP a perfectly clean link. And there's a whole bunch of other things on the side too. For example, fragment level ARQ. You want to send big jumbo packets? Be our guest. We're going to deliver the packet of the same size in the other side. And you know what happens with jumbo packets or packet fragment of the internet. If any fragment doesn't get there, it's almost a denial of service kind of thing. We took care of that for you. Yeah, we dropped in things like, for example, compression. Yeah, it's there. Same thing as IPCom.
Lossless, mathematically lossless compression.
Lossless compression. And something that G reminded me that it's not published yet, but it's coming, is the adaptivity, which we started by thinking, oh well, we are going to write a specification for varying the encoder bitrate based on network, basically on packet loss network condition, right? Which it's not a new thing. Lots and lots of people, all the cellular bonding guys do that, but they each do their own thing, right? So that's coming. But then we realized, this is a smart guy here told us, that if you have in a multi-link situation, you can actually adjust the weights on the links. So instead of calling it encoder adaptivity, we're even calling it source adaptivity. You want to talk some more about that?
Yeah. So basically, this is another thing that will be available in the it will come as a TR6.4, but it will be available for simple profile, main profile. It is friendly. The idea now is that to give you the same capabilities as the cellular bonding, or you can build a cellular bonding application. Now we test and give you the information on a link by link, what is going on a link by link, what is the health of the signal, and will allow the sender to decide what to do. He can go and throttle the encoder, the source, to change its bitrate, or maybe if we're going to have a CMAF, to select a different CMAF profile, as the guy from ATEM said, ATEM, yeah. It gives you more flexibility. But moreover, let's say you start with the 7020.22-7, but you see that your link is not the best. You can now decide to lower the amount of traffic that you send over that link, or maybe just use protection on that link if needed. It gives you much more visibility. But think about the statistics that you get. Suddenly you will be able to train your system, maybe add AI, so that you will decide which links to use, how to diverse your data, or maybe take out some services. Maybe if you are carrying, and I apologize, if you are carrying 2110, hold some of the metadata or the audio, but allow the video to pass through, or the other way around. It gives you you have more information.
Audio is more important, actually, Hadi.
Huh?
People complain more about bad audio than bad videos.
I know, but some people prefer to see the game and not hear the game. Yeah. It depends.
Well, the announcers, that's a different matter, yeah.
But I want to pick up on something I just said here about the AI and stuff like that. It's a guiding principle here on the AG that we do only what's necessary for interoperability. So in the adaptation, we make the data available. But what you do with that is up to your creativity. So we have system A, system B, they will interoperate, one works better than the other. So we foster that part too. It's just like You take two video encoders that generate fully compliant bit streams, one looks better than the other. But they are both fully compliant, fully decodable.
Right, and that goes along the argument of why wouldn't I use a WireGuard tunnel and push the data? Because then you have to manage two separate tunnels, two bandwidth. If you push it all through Advanced Profile, the tools are there for an implementer to create a fully manageable pipe with QoS, with priority, the video on top of the other type of protocols, et cetera, so that you always get everything in one place to manage.